evidence of humanity's lost sixth sense may have been found. Joe Kirschvink, a researcher from the California Institute of Technology, claims to have confirmation that humans can subconsciously detect Earth's magnetic field. Using a Faraday cage and EEG monitor, Kirschvink observed reproducible changes in human alpha brainwaves when adjustments were made to the magnetic field around them. "It's part of our evolutionary history," said Kirschvink. Magnetoreception may be the primal sense. The ability to sense Earth's magnetic field has been found in certain creatures such as birds, insects and other mammals that use the power for migration or orient to their surrounding environment. For decades, researchers have been studying this phenomenon in animals and discovered that dogs, foxes and bears also have the field-sensing molecule cryptochrome in their eyes. This work was published earlier this year. Other experts say this sixth sense harnesses its power from iron mineral and magnetite to act as compass needles, while others say it relies on protein in the retina called cryptochrome, reports Science magazine. During the recent trial, Kirschvink and his team built a Faraday cage to test the ability in humans. This structure is a thin, aluminum box that blocks out any and all electromagnetic background noise using wire coils, called merit coils. Participants sit in complete darkness, where they are only exposed to a pure magnetic field. No stimulus or interference is able to get in the enclosure. Kirschvink recruited 24 volunteers for his experiments, which he hooked up to EEG monitors in order to analyze their brain activity when exposed to a rotating magnetic field that mimics that of the Earth. The team found that when the magnetic field was rotating clockwise, there was a drop in alpha waves. This event suggests that participants were responding to and processing the magnetic field. Besides this observation, Kirschvink found that the neural response was delayed a few hundred milliseconds, suggesting an active brain response, he said. This may be linked to the notion that magnetic fields can influence electric currents in the brain that mimic an EEG signal. Kirschvink found a similar response when the magnetic field was contorted on the floor of the box, but not when the magnetic field twisted upwards or rotated clockwise. This could reflect polarity of the human magnetic compass. And since the EEG monitor was capturing brain activity and not interference from the magnetism, he believes that magnetoreception may be the primal source of this ability. The most exciting part of Kirschvink's findings is that the results of the experiments can be repeated and verified, he explained.